You know, there is a constant, absolutely microscopic drama unfolding inside you at this very moment. We're about to follow an incredible journey, the life, the death, and kind of the afterlife of your red blood cells, to uncover the surprisingly colorful story of a molecule called bilirubin. It all really boils down to a pretty simple question, one you've probably noticed in newborns or, seen in medical dramas. Why do people sometimes turn yellow? Well, the condition is called jaundice, and it's actually a clue that leads us to a much, much deeper process happening in the body. And to get to the bottom of that, we're not going to focus on a disease. Nope. Instead, we're going to follow the main character of our story today, a single, absolutely crucial molecule. Its name is bilirubin, and its journey, well, it begins right where another life ends.
So, our story kicks off not with a birth, but with an ending. The final chapter for one of the hardest working cells in your entire body, the red blood cell.
Think about this for a second. Every single one of your red blood cells works tirelessly, day in and day out for about 120 days. After that, they get old, they get worn out, and it's time for them to be retired and recycled. And this isn't some rare event. It's a constant cycle that's happening millions of times a second. So, where do these old cells go to retire? Well, they got sent to this network of specialized recycling centers in your liver, your spleen, and your bone marrow. This whole network has a really complicated name, the reticuloendothelial system, or RES, but honestly, just think of it as the body's official cleanup crew, where these specialized cells called macrophages are just waiting to break down the old red blood cells.
And it's right here, in this massive recycling process, that our main character, bilirubin, is finally born.
Okay, so when a red blood cell gets broken down, its most important part, hemoglobin, is split apart. Your body is incredibly efficient, right? So it recycles the iron and the protein parts. But what's left over is this component called heme, and that is our raw material. The heme gets oxidized and transformed into a green pigment called biliverdin, and you've actually seen this happen. It's what gives a healing bruise that kind of greenish tint after a few days. That's biliverdin. But that green biliverdin, it doesn't stick around for long. It's almost immediately converted again, but this time into a yellow-red pigment. And this is it. This is the birth of our molecule, bilirubin. But hang on, there's a huge problem. In this newborn state, bilirubin is actually toxic. It's not soluble in water, which means it can't just float freely through your bloodstream. And if it builds up, it is dangerous enough to actually damage brain tissue. So the body just created a poison, and now it's got to figure out how to get it out of there, safely. So, how does the body transport this toxic molecule without causing any harm? Well, it does something brilliant. The bilirubin latches onto a transport protein called albumin, which basically acts like a taxi, safely chauffeuring our toxic little hitchhiker through the bloodstream. And where is this taxi headed? It has one critical destination, the site of the most important transformation in our entire story, the liver. The liver is the body's master detoxification factory. So when our toxic molecule shows up, it's what doctors call indirect bilirubin. It's insoluble, it's dangerous. The liver's whole job is to process it and turn it into direct bilirubin, a brand new form that is safe, water-soluble, and all ready to be kicked out of the body. So how does this magic trick happen? Well, inside a liver cell, a very specific enzyme gets to work. Its name is a total mouthful, UDP glucuronyltransferase, but its job is simple. It grabs the bilirubin and attaches a special chemical tag to it. This process, it's called conjugation, and it's the chemical key that transforms our toxin into a harmless, water-soluble substance. And the scale of this whole operation is just incredible. Every single day, your liver processes about 250 to 350 milligrams of bilirubin. It's a non-stop, highly efficient production line that is absolutely essential for your health. So once it's been made safe, the now conjugated bilirubin is excreted from the liver into the intestines as a part of bile. And it's here that it completes its journey. Gut bacteria convert it into other molecules that are ultimately responsible for, you guessed it, the characteristic color of stool. So that's the story when everything works perfectly. But what happens when this carefully orchestrated system breaks down? This is where we come right back to the beginning. If, for any reason, bilirubin can't be processed and removed, it starts to build up in the blood. This condition is called hyperbilirubinemia. And that excess yellow pigment then gets deposited in your tissues, especially the skin and the whites of the eyes, causing that yellow appearance we call jaundice. So here's the crucial point.
Jaundice itself is not a disease. It's a sign. It's a message from your body that something has gone wrong somewhere along that bilirubin pathway we just followed.
You can really think of it like a traffic jam. There are pretty much three main ways the system gets all backed up. First, you could just be producing way too much bilirubin, completely overwhelming the liver. Second, the liver itself could be damaged, like a broken factory that just can't do its job. Or third, the exit routes from the liver could be blocked, preventing that processed bilirubin from ever leaving.
This actually explains a very common phenomenon, jaundice in newborns. See, a baby's liver is still maturing, and that special enzyme for tagging bilirubin, that UDP glucuronal transferase, it isn't fully active yet. The detox factory just isn't running at full capacity, which causes a temporary and usually totally harmless traffic jam. So after following this entire journey, you can see that bilirubin isn't really the bad guy in this story. It's not some villain we need to eliminate. It's actually a vital messenger, and it's carrying some really crucial information. When doctors measure your bilirubin levels, they are literally reading a story. It's a story about how well your red blood cells are being recycled, how healthy your liver is, and whether the pathways for waste removal are clear. It's an absolutely essential diagnostic clue.
And that really makes you wonder, doesn't it? Every single molecule in our body has a purpose and a pathway just like this one. So what other incredible stories of recycling, transformation, and communication are hidden in our own body's chemistry, just waiting to be explained?